A very good day and salam sejahtera. I would like to bid to our lecturer, Sir Badaruddin Muhammad. My name is Carr and I will start the mini project presentation for our group. And the other teammate is Jing, and he will demonstrate for our project. So let's move forward. So for the introduction, for this project, we will use STM32F103C6 microprocessor, and we design a traffic light system. So the assembly coding is written at Q software, and the system that we designed had included 3 LED, which is green, yellow, red, as what traffic light do. Besides that, we also have buzzer and 7-segment display, which will do the countdown for our traffic light project. So this project is run using a simulation mode of Proteus app. So these are the components that we use. First of all, the 7-segment in order to demonstrate how a traffic light is countdown. And this is how we control the 7-segment. We control the 7-segment based on this table, which is the like for example, when we want to display 0, then we will turn on for port 14, 13, 12, 11, 10, and 9. For port 8 will turn it off. So every number will refer from this table. And this is the LED light that we use during the project to display red, yellow, and green light. Okay? And this is how the circuits look in Proteus app. I believe my teammate will demonstrate afterwards, so I'll just skip this part. And so for the microprocessor, we have chosen STM32F103C6 as it is an ARM Cortex-M3 CPU, which is very similar to what we have learned during the lecture, which is the ARM M0 processor. So we are more similar to this microprocessor, and we can use it as our project. This is for our project. So as I said, 3 LEDs selected, which is the green light, red light, and yellow light, which represent the traffic light in our project. And besides that, we also use buzzer, which will be activated when red light activated. Right. So this is the schematic diagram for the complete circle. And for the flow chart, this is how our looping looks like. First of all, we will check for the number state, the state of the number. So normally we will start with 0, and afterwards we will check whether the button is pressed. If it's yes, then the working light will be on and the buzzer turn on, and the stop light will be turned off. And then the 7-segment will display the current number, which is the value of n for current. And then it will check whether it's between 3 or 9 or not. If it is yes, then the green light will be on and red light will be off. Yellow light will be off as well. Then we will proceed with checking the state of the number, which is n, and the number will reduce each second, like what the traffic light do. So afterwards, the looping will back to 0 again. So let's go to the second option. If the button is not pressed, then the 7-segment will display a 0. So the stop light will be off and the red LED will on. Okay. Then you will check whether the n is equal to 0 or not. If it's yes, then the green light will be off and the red light will be on. Okay. The green and yellow light will be off and red light will be on. And if it's no, then every light will be off as the thing is still counting down and we don't need to display any color for the LED. So then we will proceed to counting again and back to the beginning. So this is the infinity loop for our project. So this is the initialization part for our programming. We have used CRH, CRL, which is stand for configuration register high and low for port A and port A. Yeah, and then we also use the output data register and input data register for port A. For port B, we will only use CRL, which is the configuration register low, and IDL, the input data. And then we also introduce delay and each number, each state, and numbers for each state value. Last but not least, we also introduce initialize the count counter counter state. So this is a loop for our program. First, we'll initiate clock, port, and pin, and states at loop GPIO in it. Then, this is the part where we will initiate 1 to 9 of 7 segment and counter. After we initiate that, we will proceed to the check state. So this loop is to check whether the current state for counter. After checking it, it will display the respective number of n to 7 segment. Right. So this for 3, 2, and 1, 0. So the command for delay will initiate delay during countdown, and then command for next state will allow counter to add one value to R1, which after 1 second, so that the counter will keep on counting for each second. So when the counter reaches 9, the reset loop will set R1 value back to 0. Then the counting will start again from 0. So this command is to run the is for the button function. First of all, we'll check button as I introduced during the loop, during the flowchart section. So we will check for the state of button. Then afterwards, if the button is on, then we will proceed with the check state loop. If the button is off, then we'll display 0 and proceed with the delay loop. So alright, now we will proceed to the demonstration part, and I'll pass it to my teammate. Thank you very much.
Good evening, everyone. My name is Jing, and today I'm going to present our microprocessor assembly project. So, which is Pedestrian traffic light system in Proteus simulation using ARM STM32. So, now I will show you our simulation result. So, when the button is not switched on, when the button is not switched, it's not pushed. So, if the stop light will turn on, switch on. Okay, so the stop light will switch on, and then after that, when using this display 0, 07 display 0, and red light will display stop. So when we switch on the button, so it will start countdown for 9, 8, 7, 6, 5, 4, 3, 2, 1. And furthermore, stop light will also switch off. Okay. So when 9 to 3, the green light will turn on. Okay, 9 to 3, green light will turn on. When 2 to 1, yellow light will turn on. When 0, the red light will turn on. So it means that when 9 to 3, you are set to go. The people can set to go. When 2 is prepared to stop, yellow light prepares to stop. And 0, you stop. And you start counter again, and you infinite loop until when person is open, you reset again, and it becomes 0, and red light will turn on, and the stop light will turn on. So that's all. Thank you.